Okay, here we go. Clearing your calculator. You should have second plus. Second plus. Go down to reset, number 7. Go over to all memory, and then number 2, reset. So second plus, reset, scroll over to all, reset, and then either you should have RAM cleared or mem cleared on your calculator screen right now. That's the when I go up and down the aisles next Friday in Gym A. Yep. I want it as long as it says mem or RAM clear. That's what I want to see. All right. I'll keep reminding you of this even during the exam when you clear it. After you clear it, it's a must that you go to your mode button, go to your mode, and put it in degree mode. Okay, put it in degree mode, please. Because any sine, cosine, tangent problem, you're done for if it's in radians. We all good there with clearing your calculator? Okay, next thing. If you're going to sit there, Caleb, you got to turn your desk so you see the front, please. Okay, next thing, I asked you to get your review times out. I'm going to switch one of them, and that is I'm switching tomorrow, the Friday one, to today after school if you want to come by. Okay, because I can't make it tomorrow after school, so it's going to be today after school if you want to come by for a little review. Okay, so tomorrow's is getting pushed back to, or pushed forward to today. All right. Okay, we're going to have a lot to go over here. First thing I just want to make you aware of. I don't know if you've picked up on this or not, but the older exams here, like maybe the one you tried last night, the one I just handed you, you will see in the Part 4 section that there are 2 questions in the Part 4. And I've told you that there's only one. They changed that maybe two Regents ago, maybe they changed that. All right. So expect only one on the Part 4. All right. Don't freak out because you see 2 of them on these old exams. All right. They changed it a little while ago and they said, all right, Part 4, you're only going to have 1 question. You know it's going to be a proof. Okay. So if you're ever wondering, that's why. There's the assignment I'm recommending for tonight if you want to keep on pace with preparing. The exam you just got as you came in, the parts 2 through 3, which we'll do a few of them if we have time today. Our focus right now is on August 2017. August 2017. My suggested assignment last night was to complete it. So as long as it takes right now, I will answer any question, again, because you struggled with it, not because it looked tough, on that August 2017. Anthony, going to start us off? Okay, number 10, everyone. Go to number 10. What am I looking at here, Matt? Before I get up there. Got it. Okay, number 10, everybody. August 2017, number 10. Okay, we're doing a dilation. And this kind of fits into what we talked about yesterday when I went over that whole explanation of dilating a line. As I'm setting this up, what point am I dilating around? I'm dilating around the origin. All right, so when I dilate around the origin, we talked yesterday, what does not change about the line when you dilate around the origin? Slope does not change, and that's the key to this problem here is finding the slope of that original line, the 4y equals 3x plus 7. All right, so I'm going to ask you guys whether you tried it out or you didn't. Help me find the slope of this line. What's my first move here? Finding the slope of this line. Come on now. Let's hear from 21 first. How do I find the slope of this line?
Divide by 4.
Thank you. Divide by 4. So y equals 3/4 x plus 7/4. What's the slope of this line? 3/4. So when I dilate it around the origin, the slope of the new line will also be 3/4. So your job right now is to go through each multiple choice and figure out which one's going to have a slope of 3/4. And I believe it's choice 1, because you move the negative, it becomes negative 3x, and when you divide by a -4, it becomes positive 3/4. Okay. The only thing that'll change when you dilate around the origin is the y-intercept. All right, let's keep it chugging here. Others from this exam. Hi, Jack. 16. What am I in for here, huh? All righty. I actually like, not because of the question, Jack, but some other things we can review, because it has been a while since we talked about this concept. All right, before I even get to the question, here we go. A little review time, because it has been ages since we talked about this. These are all midpoints. E, D, and F are all midpoints. Does anybody remember what I call those segments when I connect the midpoints of two sides of a triangle? Anybody? Mid segments. They're called mid segments. There are two properties about a mid segment I need you to be aware of. Anybody remember any of them? How a mid segment relates to the, so in this case, I'll take, let me get those off so I can read them. FE, how does FE relate to AB? There's two things you should know how they relate. Remy, one thing, they're parallel. So FE is parallel to AB. And I could say that for any of these guys. I could say FD parallel to CB. All right, they're parallel. And anybody remember the other one, Emma? Half the length. Good job. So FE is 1/2 the length of AB. Okay, so a mid segment is half the length and it's parallel to the third side. Good deal. Good. Okay, now let's get to this question, Jack. How does CFE relate to the big triangle? All right. If you see in here how many triangles were formed when I connected the mid segments, 4, right? So 4 triangles make up the full one. So 1 out of 1, 2, 3, 4 for the area. Okay, so that one triangle is 1 out of 4 that represent the total area in there. Okay, so choice 4. Okay, great question though, because I got to go over that business there, which we haven't seen in a while. Nam, which one? 18. Okay. I don't like when they ask this topic this way. I'd rather have you just plug in. Okay, which lengths would make triangle KLM a right triangle? And this is an altitude. What type of problem are we involved with here? This is Hill SAS, yeah. Not the way I'd like it to be asked. I'd like you guys just to plug in numbers to the proportion. But basically, here's the deal now. I want to know when I plug in these numbers, the multiple choices combined with the 16, which one fits into Hill SAS perfectly. All right, so let's take number 1 here. LM is 13, KN is 6, and this is 16. Is the altitude involved at all now? So I'm going to use Hills here. Does this fit into Hills? That's what I want to know. Okay, so here's Hills. Oh, if I could spell it, huh? There we go. Okay, so 16 over, what's my leg? 13. Is that equal to 13 over, what would my segment I would use here? Not 6. Because I want the segment next to 13, so I would use 10. And I cross multiply and see if they're equal. Does 13 times 13 equal 16 times 10? And the answer is no. So I'm going to keep trying. All right, I'm going to keep going with this. What's next up? LM is 12, NM is now 9. All right, here we go. Hypotenuse, 16 over leg 12. Is that equal to 12 over 9? Again, does 16 times 9 equal 12 times 12? I believe it does. 144 equals 144. And there it is. Okay. If that didn't work, I keep trying the values into Hills or Sass and seeing which one are actually equal to each other. Okay. Not the way I like to give the values and solve for a missing one, but it's the way we got to do it here. Nika, then Billy. Here we go. Buckle up. Right from the get-go? Nika, right from the get-go here? Actually, what am I doing? I already copied this. Yep. And I think it was because of this problem. They were like, you know what? We can't be doing these to the kids anymore. We're only going to give one part 4, and it's going to be a proof. So they scrapped this, doing this stuff. Because I'll be, is it a great geometry question and challenging? Sure. Does it belong on the Regents? No, it doesn't. All right, so I'm going to just start fresh so everyone knows where we're going here. We got a pool here. We got a deep end. We got a shallow end. We got a little slope there. Great. The slope, floor, angle, depression, 16.5. That's already plugged in. Find the depth of the pool at the deep end. They're basically asking you, hey, I'm at the deep end here. What's the length of that segment there? Okay. Well, I know part of it's what? This part right here up is how long? 4.5. I just need to find the rest of it, which is also this length here in the right triangle that they gave me. So if I can find that part, add it to 4.5, you got the deep end depth. Is there anything, can you find out how long this part is? Well, this whole thing was what? 35 minus the 12.5 minus the 9 will give us what's left over. It was 13.5. Check my math here. 13.5. So that's 13.5. All right, so now hopefully we can get going with this. If I can use sine, cosine, or tangent. So let me turn it over to you guys here. 9, here we go. Need a little help. Here's the 16.5. What's the x? The opposite of, oh, okay, how we doing? And how about the 13.5? Adjacent. And then with those two values, I should be able to use what, 12? Tangent. Yep, so I'm going to say tangent of 16.5 equals opposite over adjacent. And it said round to the nearest 1/10 of a foot. So you guys go in your calculator. I don't have any to use, so multiply that. And then make sure you add it still to what? To find the depth. What did we talk about at the beginning? Add it to 4.5. So whatever answer you get here, add it to 4.5 and round it to the nearest 1/10. If I remember my answer key correctly, 8.5. Okay. 8.5 feet. All right, so there was the first part. The deep end's 8.5 feet. All right, now to your question, which is what's the volume of this thing, which is it. I'm not a big fan of the question, but it is what it is. So let me erase this. There's multiple ways I've seen done. This is the way I like. I broke it up into 3 different prisms. Nobody cares. Go tell somebody who cares. Okay, here's what I did. All right, I drew these over here. So I created 3 prisms. Do you see the huge one on top? I'd color them in, but it'd get real sloppy. There's a huge one on top here. There's a second rectangular prism at the deep end here. And then there's one more type of prism, but it's not rectangular. It's triangular. So there are 3 prisms right now I'm going to find the volume of and then add them together. Okay? So let's start with the volume of the big one because I think that's the easiest. So volume of, what should I call this? Big prism? Length times width times height. What do you got for me? Because all of them are there. Of that big prism on top. Length, width, and height. What do we got? Tom? 35 times 16 times 4.5. Got it. There's your top one. Everyone, any else questions there? There's the big one. Good, you, Nico. You're good there. Okay, now let me go to the little one, which is in the deep end. It's still a rectangular prism. I guess a little prism. Not very mathematical. But anybody tell me the 3 dimensions of the little one that I made there? Based on what you already know here. What's the, what am I looking at here now? 12.5 by 16 by, I just found this part already. 3.5? Hey, 12.5 by 16 by about 4. About 4, I'll just use 4. All right. Everyone good here? This rectangular prism right here, I'm finding the area. This one right here. 12.5 by 16 by, we called that 4. 12.5 by 16 by 4. And then now here comes the tougher one. This is why I saved it for last, the triangular prism. Still big B times H. What's the shape of the base? It's a triangle. So I'm going to do 1/2. What type of triangle, by the way, is that base? A right triangle. So can anybody tell me the base and the height of it? Because that's big B. 1/2. What do we have here? 4 times 13. What do we? Oh, we found this earlier. So 1/2 of 4 times 13.5. That's just big B. And then what about the height of it? This is why this is getting crazy. From here to here, yep, it's already labeled for us, 16. And then what am I going to do with all 3 volumes? Add them up. How about that, Nico? I know, it's ridiculous. Okay, so I just cut it up into 2 rectangulars and a triangular. And then I need that answer to go to the next one. What is it, 25 something? I actually have it. Never mind. Third note, 3752. $3,752 cubic feet. We all good? Okay, and then like you think you're done, like you got through all this, and then you're like, oh, a garden hose. Now I got to fill the darn thing. Imagine the kids taking this exam, going nuts in August. So I got this garden hose to fill it, and you're like, oh, this is not too bad. I can use the volume. I know this deal. But then all of a sudden they bust this out. Oh, you're not going to fill. You're going to fill it 6 inches from the top, and you're like, oh, give me a break. Okay. This one right here is if I fill it to the max, right? All right, but now I'm only going to fill it to the top so it doesn't, to 6 inches below so it doesn't overfill. So what I'm going to do right now is basically find out how much empty space there is, 6 inches from the top, and do what with that and the total volume to find the volume of the water. Subtract it. Everyone all right with that? Okay, so the empty space, how could I find the volume of the empty space, which is 6 inches from the top? 16 times 35 times, not 6, 6 inches from the top. So 0.5 times that, we're going to say? 0.5, not 6. Everyone see why? That's in inches. We're in feet. Okay, so the volume of the, I don't know, I'll call it the air, empty space, 30, what was it, 35 times 16 times 0.5. That's just the empty space on the top with the spot on top with no water. That's the volume of it with no water. And then I'll take that and subtract it from the total. And that'll be how much water I have in the pool. So the total minus the volume of the air. This is driving me nuts. And then I'll leave it at this, just so I can go on to other questions here. I don't have to finish it. You convert it into gallons using this conversion, turn it into gallons, set up another ratio that says, all right, 10.5 gallons per minute. Put the gallons across from your gallons, but remember your answer is going to be in minutes. So what do you have to divide by to get to the nearest hour? 60, yeah. How about that question? Yeah, I'm sure you did. They've toned it down a little bit, but all good there? Or anything else you want me to go over on this problem? Or you're coming next, Billy. Settle down. Anything else here? All right, Billy. You're up. 15. What are you going to have me do here? By the way, while we're doing this now, any issues with seat numbers, what you're bringing to the exam next Friday? Everything's up there. Just take a peek on Aspen. Everything is there for you. You don't need to email me anything. All right, Billy, here you go. Sine, cosine, tangent, right? You're finding an angle now instead of a side, right? Because it's a right triangle. Going to use SOHCAHTOA. The 1, anybody want to help here? The 1 is what to the angle x? That's the opposite side. And how about the 12? Adjacent. So I'm going to use tangent on this problem. Tan of x equals 1 over 12. Emma, I think you asked this a couple days ago. What's the deal now if I'm looking for an angle? Inverse. I always use the inverse when I look for an angle. I never cross multiply. So the inverse of 1 over 12 in your calculator. That's why you need to be in degree mode. If you're in radians, is the answer going to be there? I have no idea, but that'd be real filthy of them. And then you go nearest hundredth of a degree. Good, Billy? Great. Jack. Oh, and he said, please. Look at that. What great manners. So I'm teaching my 2-year-old to do now, Jack. What's the word? What do we say? I don't know how to deal with this right now. This is why I don't know how to deal with it. You might want another point of reference there. Okay, Jack, bottom line, I won't spend the whole time doing it, but you got to use the sector formula, which is either on your cold hard fact sheet or you know it already. Plug in 512 pi over 3. Because here you go. Ready? Area of a sector real quick. You got measure over 360 times pi r squared. Okay, good. You're going to plug in your 512 pi over 3 over for the area. You're going to solve for the measure because it's asking for the angle measure over 360 times find your radius, pi r squared. You're going to solve for m. However you solve for m, that's up to you and your algebra skills. But here's the problem, though. Reread it. What do I need my answer in? This is going to get it in degrees. So then you go to the formula sheet where it's going to say 1 degree equals pi over 180 radians. So whatever you get out of this, put it over the degrees and solve for how many radians. All right, this one's dying. Other questions? This one's garbage. Jeez. Yeah, John. 1. The first one. All right, what's your excuse? Go ahead.
I get that you can't get a triangular cross section in a cylinder, but what about a rectangular prism?
If you cut it, let me try. Visual always helps here, right? I don't know if I'll be able to. Good question. We'll see if I can do this real quick here. Okay, everyone calm it down. Okay, here's your rectangular prism, right? And I'm going to try to do a cross section here that results in a triangle for you. Maybe. If I close some of these, we'll go a little faster. Guy is unbelievable. So basically slicing it off the corner there. Okay. Good question. Others we want to go to on August before I go to the June one. Anything else? Last call, August 2017. All right, new exam we just got. Let's do this. Some random problems. Here you go, 32, everybody, 32. Something we have not reviewed, specifically the wording of what I need to write. Go ahead, graph both triangles right now. Number 32 on the June exam you got as you came in the room today. Let's graph them. Everything. Now, hey, this is one I can talk about here while you graph it. That graph you're doing right now in pencil, but the work we're about to do has to be done in pen. That's what I'm talking about, graphs only done in pencil. All right, so what you're doing right now, next Friday, can be done in pencil, but when you start writing the work on the white space, it's got to be in pen. Yeah.
Well, just like give us a 0 on the column if we do it in pencil.
No, honestly, it depends on how we feel that day. We've had kids come back, had to give them a call at home and say, come on back and fill it in pen for us. Yep. But usually I look through it before you hand it in anyway and say, hey, make sure you do this in pen so that doesn't happen. And have we gone over why it needs to be in pen? So I don't change the answers, even though I would not do that for any of you. What's that?
If someone did change it, wouldn't they see that the handwriting completely changed?
If you're really serious about plagiarism and copy and handwriting, you know, if I really need a student to pass, you know, and which would never be the case. All right, guys, here we go. I'm going to get going. If you still have to graph it, keep finishing up. All right, first off, give me a transformation, rotation, reflection, dilation, translation that would map ABC onto DEF. Give me something that would map those on. So you do this to A, it goes to D. Do this to B, it moves to E. Do this to C, it moves to F. All the same one here. Okay, it's got to be the same thing we do. And I really only see one thing we could do here. Christian, see anything? Okay, here we go. It's a reflection, definitely, over this line right here. Or lines, huh? Over this line right here, and yes, he is correct. That line is x, not y equals x equals -1. Any vertical line. So you could write that out in words if you want to get fancy and go to the symbols. What's the symbol for reflection? Lowercase r, x equals -1. Or you could write it out in words too. That's fine. All right. Yes, Nam. Does that work? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Back 2. 1, 2. 1, 2. Back. Yeah, that looks fine. Wait. A translation of. Okay, and you got to have the 0 in there. What's up, Anthony? All right, there you got me there. So yeah, it need to be a single one. Okay. Way to read it. Way to read it. We all good here because this is not why I wanted to do this one. Emma, go ahead. No, because it says DEF is the image. So you got to be reflecting ABC. Okay? Everyone good? Because that's not why I want to do this problem. It's the second part. Tell me why they're congruent. We need specific wording in here. All right, what did you just do? Oh, what did you just do? A reflection. So we're going to start this off with a reflection is a, there you go. Which does what? There you go. It's like you never left, right? Which preserves distance and angle measure. You could also say side length instead of distance. That's fine. Distance and angle measure. And now you can impress whoever is reading this. It won't be me. Henceforth, in conclusion, thus, subsequently. I can't even spell that, so I'm not even going to try. I'll just stick with the old 4-letter. Thus, triangle ABC is congruent to DEF. I just want to make sure we got that wording down pat. Okay. Pretty, not bad. Yes, Bella. I don't think so. As long as you had that part there, I think you'd be fine. All right. Emma, do me a favor in the box. Grab the box of compasses. You're going to need your compass for the next one. Usually I don't like wasting time because you guys can look up these videos on your own. 25, everyone. Compass and a straight edge out, please. Compass and a straight edge. Compass and a straight edge. Here we go. I usually don't spend time, but spend some time on this one. Okay, here we go. So we can get to another one. Altitude. Coming from J down to ML. What's your knowledge of an altitude? What should this do? Altitudes don't bisect. Form a right angle to the opposite side. That's what we're trying to do. Give me a segment starting from J, drawn to ML, that's perpendicular to ML. And this is not the fish. This is why I'm doing it, because you guys think the fish is the answer to everything. Most things, I'll agree. Most things, you got me there, but not this one. What do we have? Put my compass where first? On J. And then try to make an arc that does what? Intersects ML in 2 spots. I don't think that's going to happen. So what can I do so it will happen? Extend ML so you have an arc that intersects in 2 spots. Yes. Okay, I made an arc that intersects twice. Next step. How many points of intersection do you have? 2. That your compass point goes on each one now. Make 2 more arcs. These arcs should be intersecting. And then you take your straight edge and line it up with J. And there is an altitude. Okay. Anthony. Yep. Yep. You could do this above instead. Okay. No, I doubt we'll go over another one between now and Monday, our last day of class. Just know I'm coming in. There's a whole website dedicated to finding which one you need. I will say last couple of years, it seems they've done something with a circle. Square, hexagon, equilateral triangle, a tangent line. They've done something with the circle. That doesn't mean they'll do it again this June, but all right, just know, bottom line, know them all because there's one that's going to be guaranteed on there. All right. And number 8, let's go backwards a little bit. Number 8, just more circle facts. Have your cold hard facts with you so I don't have to tell you which fact this is. You have 2 chords that intersect. One bisects the other. Okay. BC is 12, and it's getting bisected. It says DF bisects chord BC. So what do you want me to put on CE and EB? 6s. Okay, because it's getting bisected. The whole thing was 12. And then what do you want me to put on DE and FE if FE is 5 more than DE? Where should I put my X? DE, and then on EF, 5X or X plus 5? X plus 5. All right, now you got to know the theorem so I can set up an equation to solve. It's on there somewhere, 2 chords intersecting. 2 chords intersecting, what's the theorem here? Because it's not whole times external anymore. Tom, what do you got? Okay, give me numbers actually in my diagram now. 6 times 6, part times part, yep. There you go. Part times part. There it is. All right, so you get 36. We get x squared plus 5x. Oh boy, what's going to end up happening here? Factor. Now, hey, whoa. Before we start whining and complaining that we're going to have to factor, you don't if you don't like factoring in this problem. It's multiple choice, isn't it? The answer's there. You could just take each multiple choice right now, plug it in for x, and see which one equals 36. You got the answer. All right, well, actually, you don't because you'll see at the end why you don't have the answer. Okay? But you could do it that way instead of factoring. Find the value of x. All right, moving on. We're going to factor because we're an above average class here. So I'm moving the 36 over. X squared plus 5x minus 36 equals 0. Quickly, anybody know 2 numbers that multiply to negative 36 but add to 5? Multiply to 36 but are 5 apart. 4n, 9. What about the signs? How do I make them add to a positive 5? Minus 4 plus 9. X equals 4. And x equals negative 9. Let me finish this problem, please. Anybody want to tell me something what's wrong? No negative side lengths or no negative segment lengths. All right, but the answer is not 4. That's the problem with this one. You got to read. You're finding what segment? FE. We didn't label FE X. We labeled it X plus 5. So it's got to be 9. Watch out for that business. You got to stay for 2 hours. If you borrowed a compass or a straight edge, put it back. 2 more days of review. We're here today for a session.